Okay, yeah, we're moving on to the fourth problem. What a diagram there, and this diagram is simply illustrating a scenario where we have an object P suspended, a particle of P of mass m kilograms. Now, the moment it is with mass, we know that the weight is going to be 10 m, because that's mass times g. It is attached to one end of a light inextensible string of length 2.6. The other end of the string is attached to a fixed point on the horizontal ceiling of and the string is taut. The particle is held in equilibrium by a force of magnitude 35 newtons, acting in a vertical plane, which is perpendicular to the ceiling and connects the string. Now the force acts in the direction perpendicular to the string. See diagram. Tension in the string, T newtons. Well, it looks like T newtons is solved together, the one in the string. And the vertical distance of P from the ceiling is 2.4. So if we can imagine here, looks like this is what we'll get when we do our components where we have t cos, let me refer to this anyway as maybe theta. So that will be t cos theta, and this will be t sine theta. But remember, we know this distance is 2.4. So I've got the opposite side of the hypotenuse. I'll see what we can do with that. Then find another order the value of m and the value of t. So I'm going to find the m of theta first. Well, theta, because I've got the opposite end and hypotenuse. So I'll use outside. So let me see what I can do there. I'll push my calculator aside and say same function outside, open bracket side 2 points. Let me raise my calculator, it's 2.4 divided by 2.6. I close the bracket. I think the end of that given there is 67.4 if I round to one decimal place. So I come and say that my theta is 67.4 degrees. Then once I have that in mind, I can come and redraw my diagram properly. That what I'm seeing is a scenario where I've got T and I've got looks like 35 here, and I've got 10 m below. Let me raise a bit my screen so I can write 10 m, and this is our horizontal. So we saw that this angle is 67.4 degrees. And then let me just double check so that we can make a necessary errors. Oh, that's 67.4. But we're told this is a right angle. So what it means is 67.4, and this end we have only made that. Then I'll bring my calculator and say, well, if I ignite, then I subtract 67.4. The result that I'll get is the smaller end. So let me read it 22.6. So it means this is 22.6 degrees. So this is my y-axis. That is my x-axis. So I'm interested in finding the values of let's say m and t. So I've got two unknowns. So what I'll do is I'll try and check from the information. Is the system in equilibrium? We are told the system is in equilibrium. So there's a balance between the left and right side of both the x and y. So let me start with the x. If there's a balance of putting equal signs, say what do I get to the right side? The right side I'm meaning this direction. So I'll only have this component, which is going to be 35 cos 22.6 degrees. What about to the left side? Now, the left side of the t cos, well, as t cos 67.4 degrees. Looks like that's all that I have in the x. But if we check on the equation, it looks like we can make t subject to formula leading to the value of t. So that's cos 67.4 degrees. Numerator and denominator cancels. Then I'll go down to say, but my t in actual form is going to be equal to, when I do the calculation, that's let's say push 9 calculate on say 35 and cos 22.6 all over cos 67.4. Calculus giving me 84. So it looks like my tension is 84 newtons. or number. And what I'm left with is the value of m, or maybe the value of m on the y-axis, where I've got two components. If we check clearly, I've got t. I'll put my equal sign here. I've got t sine 67.4 degrees as I go up the plane. 60 t sine 67. Same applies here. As I go up the plane, I'll have 35 sine 22.6. So I can say plus 35 sine 22.6 degrees. All this is equal to what's the noise, which is this component here. That's 10m. But remember, t we got it already as 84. So I can rewrite my equation is 10m is equal to where I have t here is 84 sine 67.4 plus 35 sine 22.6. But once I'm looking for the value of m, I'll divide both sides by 10 like this. And the 10s will cancel. Therefore, my m will be equal to. Might give my calculator to this problem now, simplify. We are saying it's 84 sine 67. So it's 84 sine 67.4. And there's a plus, there are two of them. 35 sine 22.6. Then find the result. I'll divide all this by 10, which will lead me to 9.099. Now, to want to small place, it looks like this me 9.1 kilograms. So that's the value of T and M on that problem. I hope you guys will find this interesting. We're still proceeding with the next problems to be solved.